All right, so this is going to be section 11.3. This is dealing with the ratios of areas of similar polygons. So what we did was, reading this, it says, we learned in chapter 6 that the ratio of perimeters of similar polygons is equal to the ratio of corresponding side lengths. So in other words, if we had a side length of polygon 1 and the side length of polygon 2, we could say that those two are proportional to each other, which means we can set up a proportion that looks like this. A is to B, okay? So we can say the same thing similar about the area of polygons. It's just a little bit different with regards to the formula that we're going to use. What this is saying is that if we take the area of our first object and we take the area of our second object, if we take the ratio of those two, remember ratio means division. Ratio means this divided by this. So the ratio of the area of the first polygon to the area of the second polygon will be equal to the ratio of one side squared over the other side squared. So the area of this polygon right here divided by the area of this polygon here will be equal to this side squared divided by this side squared. Now keep in mind, it has to be similar polygons. So if it's a rectangle, it's got to be another rectangle. If it's a square, it's got to be another square. If it's a triangle, it's got to be a triangle that looks the exact same thing. They have to be similar, and you learn that in previous chapters. So let's just go through a couple of examples. This will be fairly quick. Our first example is talking about flat screen TVs. It says a small flat screen TV is 24 inches wide and 18 inches long. So that gives us the dimensions of a small one. Okay, a larger TV is similar to the smaller one. The area of the larger TV is 972 inches squared. So it says solve for the width of the larger TV. So in other words, we need to figure out what the missing width is based on knowing that these two are going to be similar to each other. So what we're going to do is we're going to set this up as our formula shows. So what it says is we can take, since we're looking for the width, we're going to say that the smaller width, and I'm going to say smaller width is the same as SW, and we're going to call the larger width LW, but we know that the smaller width squared divided by the larger width squared is going to be equal to the small area, and I'll write that out so you can see it, divided by the large area. So what we'll do now is, now that we've set up this proportion, we can actually just plug in what we know. So off to the side here, the smaller width, we know that. The smaller width is going to be 24 inches. So we know it's going to be 24 squared. The larger width is what we don't know. So that's what we're going to call W squared. And then we have our small area. Our small area is a rectangle, so we can do base times height. So that's going to be 24 times 18. And 24 times 18 is equal to 432. So we have 432 inches squared. Okay, so that's going to be what goes on the top here. That's what our small area is. Divided by our large area, which was given to us, 972. So again, now that we have this proportion set up this way, we are using this formula. Now we're just going to solve this proportion by cross multiplying and dividing. So 24 squared is equal to 432. I'm sorry, 576. Scroll down a little bit here. So 576 will be on top. W squared on the bottom equals, again, 432 over 972. So now we're going to solve this proportion. Remember, proportions are solved by cross multiplying. So we end up with 432 W squared equals 576 times 972. So we have 432 W squared equals 559,872. We divide both sides by 432. And we get W squared equals 1296. Take the square root of both sides, and we get W equals 36 inches. And again, that seems like a lot of work, but it really isn't. You set up your proportion, you cross multiply, and then you solve for your missing piece. Okay? So 36 inches, again, all we're doing is using the formula from the previous page on your foldable. So this second one is very simple. Let's just quickly go through this together. It says find the ratio of perimeters. Well, in this case, the ratio of perimeter is going to be the same as the ratio of the sides. So if I know that these two are similar, then the ratio of perimeters is just going to be from one side to the other. The perimeter and the ratio of perimeters and ratio to sides is always the same. So we just say 10 to 18, which is 5/9. So that's it for that one. And then our ratio of areas, that's where we use the sides again. I know the ratio of areas is going to be the same thing as the small side. So we'll call it small width squared, and I'm just going to use width, it doesn't matter what you use there, over large width squared. And that's a ratio. So we take the small one, which is 10, so 10 squared over 18 squared, which ends up being 25/81 when we reduce it. Okay, so this one was pretty short. Hopefully that makes sense. Take the really quick Edmodo quiz if that's what's been assigned to you, and I will see you in class.